So this class is a follow-up if you have completed the object-oriented concept, in which we basically learned to define a basic class. Now we will see the implementation of a basic class in Java in this lesson. After completing this lesson, our hope is that you should be able to define a class, you will be able to define object, define a few variables, some keywords, being able to execute a simple program, and at the end of which there will be an exercise in which you will be expected to define some classes and run tests against them. So one of the problems when we design software programs is that, if you have designed something, how do you really test whether what you have built is correct? And that is one of the topics, one of the areas that we are going to cover, that you will define a class and then you will write a test whether you have been able to define it correctly. So, for example, we have been discussing classes like mobile phone, orders, order entry, customer, date, form, and as you go on a web page, you can order a mobile phone from a e-commerce website. But there are basically many such objects that are going to be interacting with each other. The focus of this class is to define one such object and examine how you can implement that object, create that object from a class in Java, and then be able to test it. So, how should a class be structured? In Java, we need to really declare a class, and then we need to declare fields, what are called member variables of a class. And of course, later on in the classes, we will discover different types of these fields. But for now, let's just say that all those things that you were defining as attributes in the object-oriented lesson will now become here fields. And what kind of methods, or if you want to put some comments, how do you define those things? So let's take an example of this class called mobile phone. It has a class declaration, and please pay attention to the way the class is declared. Public class mobile phone, that is the class declaration, and underneath this class declaration you will have different member variables. In this case, mobile phone ID, description, some color code, some price, quantity. All of these are actually field declarations. And then you have the methods. For example, in this case, the method name is display information. It does not return anything, hence it's called void. And then we are just printing out some values using some system function called system.out.println. We will go into the details of these functions slowly, but the objective of this class is that you should be able to rapidly define in a lab environment a new class and be able to quickly act on it. So I just wanted to give you an example of this class in a Eclipse editor so that you can see it. The declaration is called public class mobile phone, and inside that mobile phone you put in a parenthesis, and that's where your class scope starts. Inside this parenthesis, now you can have different member variables declared. So for example, mobile phone ID, and you can initialize these attributes to the values that are relevant for them. For example, here mobile phone ID I have declared as integer and I have set a default value as 0. Similarly, for string, for description we have, which is of data type string, we have declared it to be some default value of description required. Similarly, there is a attribute called color code which has been initialized to a default value, and characters are given in single quotes. We have taken price, and price is being taken as a double because mobile phone can be priced as 20.3, right, 2000 point something. So for that, the right data type is double. And then we have a variable called quantity in stock, which is just trying to figure out how many numbers of mobile phone there are. And we have selected this to be integer because there is not going to be 1.5 mobile phones. It's always going to be integer, a whole number, and hence it is being taken as an integer. Of course, somebody might argue that can there be -1? Yes, but for now let's deal with positive integers for this specific quantity. Then we have a method. This method called display information uses a signature called public void display information, and inside this basic method we are printing out the values of whatever we have here. So right now I'm not going into the details of how we write these things. Please imitate and do these things, and as we go further I will explain each and every line of what this means, right? So, but the basic purpose of our exercise today is to see how to implement a class inside a Java. So the class name, as you can see, I have stored as mobilephone.java. This should be same as the class name here. And usually it's a good practice to actually name your classes with capital letters. And it's also a good idea to only define one class in one file, but there are situations where you may want to define multiple classes in a file. Other important things to notice here is that anytime I want to put a comment in the same line, I use the syntax called //. So for example, if I want to put a comment here that default color code is U, I can write it here. Now the comments are something that compiler will skip over. If you want to write a comment on the same line where you actually have code, you can put // and anything after that is taken as a comment. Similarly, you can write a comment on a individual line by itself, right? And in this line, this comment merely means that this line has to be skipped by the compiler. There's nothing else on this line. So comments are helpful because they help us kind of identify what we are doing. These are mostly for ourselves. They're not for the compiler. They improve the readability of the code. And similarly, it is good to have same indentation. So as you see here, I don't have everything in one place. It is always a good idea to have everything starting from one column. It improves the readability of your code. Similarly, I should correct the situation here as well. Right? Now, if you see this display method, you see a curly brace after this. This indicates that a function is starting here and it is ending here. And after that, we end the class itself. And your Eclipse editor will actually tell you that this one corresponds to this bracket. Now, if there are no errors, you will not see any errors in the Eclipse editor. But suppose you do some mistakes, like you forgot to write a class name, you will start to see errors like this over here. And it will say syntax error on token public interface expected. So something is expected here. And what is expected here is the keyword class. So unless your program is syntactically correct, the compiler will refuse to compile it, and it will give you the error that you're looking for. Now, as you saw, there are curly braces, there are parentheses, there is a semicolon, there are commas, there are single quotation marks, there are double quotation marks, there are single line comments, right? You can see everything over here, right? These are the curly braces, these are the semicolons, every statement is terminated by a semicolon, When you declare a string, you have to use double quotations. When you declare a character, you have to use single quotations. And you see the comments which are double marks, right? And then let us see where we can find a comma. Okay. Now, once again, syntax for declaring a class looks like this. Class identifier, and before that there is a modifier called public, private, protected. We will go into those details later, but for now, let's declare our class as public. And for example, here you have a mobile phone, and you are declaring two member variables here. You have open and curly braces for the mobile phone class, right? Now, as a small quiz here, select the class declaration that adheres to the class naming guidelines. I have 4 options here. Which one do you think is correct? Class mobile phone, public class 201 Android, public mobile phone, public class mobiles. What do you think should be the right answer to this problem? So once again, our question was, in this quiz, which of the following is true? So hope you had a chance for a second to think over it. Let me give the answer. The answer is A, because it just says class, C is lowercase, and the class name is any string. Now, why the other 3 are not the correct answer is because in the case of B, the class is spelled with a capital C. Public is correct, some name of a class is correct, but the issue is the class is capitalized. This keyword should all be lowercase. In the case of C, we have not even mentioned class. So the compiler is going to give you an error. In the case of D, what we have is that we have public, which is correct. We have the class name, that is some class name. But the issue we have is that again the class is capitalized. So there also again we have that issue. So the other aspect is that you also have initialized all the variables. Suppose you don't initialize the variables. Is that okay? That's okay. But then you're leaving it to the compiler to actually assign whatever is the default assigning that it can do for integers. So it's a better idea that you initialize what is expected of it. For example, if you don't initialize anything to string, right, then the compiler will assign it some null value, null string, right? But suppose you forget to initialize, then you run into these kind of issues. So it's generally a good practice when you declare a variable inside a class to give it some default value. But if you're not giving a default value, then just remember that you will have to set the correct value whenever you think you have the right value for it. So this is what is called as initialization, and all initialization is done, can be done at the time when member variables are declared. Now we will obviously go into huge details of how initialization works, but for now it's a very basic class, and what we're trying to do in this class is to understand that you do have the flexibility of defining the initialization for these member variables at the time of declaring them inside a class. Now let's look at what Java defines as the signature of a method. Signature of a method is very easy to understand. First, it defines what kind of method it is. It is a public, private, protected. We will go into the details of what these means. For now, what I wanted to do is just declare all methods as public. Return type is what data type this method will return. Now, void is very special. If the method is not returning anything, then you say it's a void. And then after that, you have the method name. it can take some arguments. In this case, it is not taking any arguments. It's a zero argument method. And then the method body starts by putting a curly braces. And the method body ends here with the end of another curly braces. And whatever is inside this method is what constitutes the method code block. Now we will run the lab inside the Linux terminal that has been provided. So as you will see, there are multiple Java programs available here. One of them is quotation.java. This program has a public class quotation and has a member variable quote, as you can see here, and it has one method called display, which basically prints out the value. Now, to run this, first we have to compile this program. So what we are doing is we are invoking the Java compiler, also known as Java-C, and we give it the Java file name. We press enter. Now what you will notice is that there is a new class file that has been created. So what has happened is that Java-C has actually compiled the .java file into bytecode, represented by quotation.class file. Let me open the quotation.java file once again. Now you will not see any main program here. It doesn't have that special main function that is going to be invoking this program. We have written instead another program called quotation test.java. If we study this program, it has a main method. This main method invokes an object, creates an object of type quotation using this line called new quotation, and then it invokes a method in that class called display. So let's compile the quotation test as well. And let's to double sure that the quotation test is now compiled. What we can do now is run it. We call it quotation test. And to run it, you don't need to say the dot class, just say quotation test. And here you see the output, welcome to Upskill Mantra, good Java developer program. So now your responsibility is to run the same thing for mobile phone test. Compile it and run it. That's an exercise given to you. Thank you.